Hello, stats students. Today we're going to be going over a pretty quick lesson on geometric distributions. Yesterday you learned about binomial distributions, and geometric is another type of distribution for a discrete random variable. So let's talk about the characteristics or conditions that you need in order to determine if a distribution is geometric. And even more than that, geometric as opposed to binomial. All right, so let's see. The trials are independent. Still, each trial can result in one of two outcomes. So we've got a success or failure situation again. The probability of success is the same for all trials. And X is a geometric random variable with probability of success pi or p for each trial, such that here's your formula for geometric. P of x is equal to 1 minus pi to the x minus 1 times pi. Here's really how your geometric distribution is identified as different from a binomial, is how your random variable is defined. The two distributions are very similar except for how you define x, and x is the number of trials until the first success is observed. Okay, and this is including the success trial. So in binomial, it's the number of successes observed, and in geometric, we're looking at the number of trials until a first success is observed. Calculator pathway. Geometric distributions are right under the binomial. So if you're calculating a probability for a single value, write the formula. Just like with binomial, this formula up here. And you're going to use geometric PDF with an input of P, your probability of success, and X. Okay, same situation over here with multiple values. The calculator reads left still. So you have to have your probability statement of being less than or equal to whatever value you're looking for. And you're using geometric CDF, input P and X again. So now that you know a lot about binomial, this is really quick and easy. Because it's really very similar. The only difference is how you define X. All right, let's do this first example. A top NHL hockey player scores 93% of his shots in a shooting competition. What is the probability that the player will not miss the goal until his whatever try? All right, so let's talk about this. Our random variable that we're dealing with is X. And this is the number of goals until you miss or he misses. Probability of success in this case is a miss. So you gotta kind of be careful, because actually in this case, probability of success is kind of a failure. In Q, a fail would be he makes it, because if he makes it, then we keep going. So it might be important to list these things out before you get going. All right, what's the probability that he misses on his 8th shot? Here's your formula. 1 minus 0.07 to the 8 minus 1, that's 7th power, times pi, 0.07. You can crank that out, or you can use geometric PDF with a p-value of 0.07, x is 8, and you'll get 0.04, so a 4% chance. What about, the 5th try? 1 minus 0.07 to the 4th times 0.07. You can either crank that out, or you can use geometric PDF 0.07 and not 4, my bad, 5. And you should get 0.05 before his 10th. So this would be the same as the probability of x being less than 10, because before his 10th implies 10 is not included. So in order to make this work, we have to write our probability statement in a less than or equal to format. So less than 10 is the same as less than or equal to 9. Luckily, because you think about it, we got 8, 7, 8, 9, 10. Less than 10 includes all of those values, which is less than or equal to 9. Okay, so we're going to use, in this case, geometric CDF. Success is 0.079, and you should get out 0.479 approximately. After his second will be the probability of x being greater than 2, which is the same as 1 minus the probability of x being less than or equal to 2, since 2 is not included. 1 minus geometric CDF 0.072 is 0.8649. Between the 3rd and the 5th, so we're inclusive, the probability that we're between the 3rd and the 5th is the same as, so if you look at it, 2, 3, 4, 5, 6, 7, between the 3rd and the 5th, inclusive is right there. So this is the probability of x being less than or equal to 5 minus the probability of x being less than or equal to 2. So this is going to be, let's see, geometric CDF 0.07 and 5 minus geometric CDF 0.07 and 2. Okay, this is approximately 0.3043, and this is 0.1351. So the probability is approximately 0.1692. Alright, so I hope you guys are feeling kind of comfortable with this now, because it's nothing really too new from yesterday. I'm going to leave off examples 2 and 3 for now. Why don't you guys try example 1, pause the video, and then when you're ready, play play the video because I'm going to fill all the answers in now. Okay guys, so here's all the answers for you to check all of your work. Make sure if it's an equal to situation, you show the formula. You can just crank out the probability right here or use geometric PDF, either way. CDF, if it's an interval, remember all of your probability statements need to be rearranged to be less than or equal to. I'm going to have you skip 2 and 3 just because you have enough practice to do on your homework. So right now, you guys can go complete 7.5 practice, numbers 4 through 6. Determine whether the distribution is binomial or geometric, and then find those probabilities. See you in class on Friday.